Okay. So as you remember in our previous lecture, we've gone through the part of the largest cranial nerve. This is particularly the fifth cranial nerve or the trigeminal one, yeah? Where we remember that important aspect of that nerve was that it is the one which is propagating the general senses through the part of the head, yes, particularly the region of the face, as you remember. Although here, I told you one important thing, not to, let's like that, mix it with a part of the facial nerve, which is the cranial nerve 7, yeah? Because in this case, here, particularly in the part of the cranial nerve 7, we do have other type of the sensory information, and although it's still a general somatic sensory information, yes, which is also associated with the facial nerve. But in this case, the sensory information is very small. If you remember when I was showing you the diagrams, I showed you that the trigeminal nerve with three of its divisions, ophthalmic, the part of the maxillary, as well as the mandibular divisions, they were literally propagating the sensory information through the whole face. But posteriorly, more posteriorly at the region of the auricle, so the part of the ear, yeah, we had a small region where we have particularly the general somatic sensory function, which was propagated, information which was mainly propagated by the cranial nerve 7, as well there was short part of the ninth, as well as some 10th, and so on, but mainly the 7 is cranial nerve, which is represented there, okay? And now you would ask, then why, okay, the trigeminal nerve was clear, but then now why the cranial nerve 7 is called facial, yes, in this case. And here, because if it's facial, it means that it is associated with some functions of the cell, of the face, sorry. So if it's not sensory, because we saw that, okay, sensory was in the case of just a small area, then what is left now for us? So in the case of the facial nerve 7, which we have, and you can see particularly here, that's how it looks like. We do have several more type of the functions, yes. And again, subdivision is because it's the mixed type of the nerve, as you remember. So it contains both the sensory and the motor type of the fibers. You can see that in case of sensory, we do have both a general somatic sensation as well as we do have a special sense, particularly the visceral one, where, if you remember, we've talked about the important type of the sensory propagation, sensory information propagation, and that was the taste and smell, yes? Where the taste particularly anterior two-third of the tongue was dependent on the cranial nerve 7 or facial nerve. So as a result, you can see that sensory information here is not that extensive, let's like that, is not that wide as it is in the case of cranial nerve 5 or trigeminal. Although from the other side, if you remember in the case of trigeminal, we had much smaller contribution in the motor type of the innervation. And this motor one, if you remember, was mainly the part of the branchial type of the motor function, particularly associated with the muscles of the mastication, yeah? But all of the other muscles which are presented in the region of the face, which are mainly associated with the facial expression, remember I told you even that, as well as we do have the part of the small muscle associated with the ossicles, so smallest type of the bones in our body, which are localized in the middle ear. Particularly, we have there the stapes, and the stapes is associated with the stapedius muscle, and stapedius muscle is also dependent on the motor control of the cranial nerve 7. Plus, if you remember, I said that because I put for you here a very important sentence as the note. In the part of the cranial nerve 5, let me show you it here. We've talked about that there are two muscles of the middle ear which are attached to the part of the ossicles. Yes, one of them is the tensor tympani muscle, which is attached to the malleolus, and as a result is associated with the cranial nerve 5 motor innervation, and vice versa happens in the case of cranial nerve 7. Here we have another type of the muscle, which is stapedius muscle, which is associated with the stapes, as you can see, and as a result here we do have the innervation of the cranial nerve 7. So coming back here, that's why we again have the same type of the information, which you can find here in the region of the this particular slide. What is also interesting, to be honest, in the case of the facial nerve, but it's also not only about the part of the facial nerve. Do you remember when we were talking about a general classification of the cranial nerves, we said that the autonomic innervation, which is the part of the motor innervation, yeah, is very much associated with the part of the cranial nerves. What does it mean? I told you that in case of the motor type of the control, we have two types of the innervation. It can be either somatic. Yes, that's what you see particularly here as the branchial motor, yeah, or main motor. And the second one is autonomic, so parasympathetic or sympathetic type of innervation. In the case of parasympathetic, I even told you that this is what we call also craniosacral type of the division of the autonomic nervous system. And from the name, it already tells you that some cranial nerves will contain the parasympathetic motor output, yes? And if you remember, I even told you that that type of the cranial nerves, we have only 4, and one of them, as you can see particularly here, this is the cranial nerve 7. If you remember, I told you that also previously that we've talked about the parasympathetic innervation, and we said that the first cranial nerve which has or contains this type of innervation was the cranial nerve 3, or oculomotor, where we have the part of the Edinger-Westphal's parasympathetic nucleus, yes, at the level of the midbrain particularly, and that's where we had the particularly the parasympathetic autonomic output. So as you can see, in the case of facial nerve, this is the second type of the cranial nerve, which also contains the parasympathetic innervation. That's why you can see that according to the functional category, we can see that we do have a branchial motor, we do have a parasympathetic, we do have a visceral sensory, as well as we do have the general somatic sensory type of the functions. And as a result, in the case of a parasympathetic, you will ask what should be the innervation of the parasympathetic part of the autonomic nervous system. So simply, anything what is not dependent on our own desire or it's not voluntarily controlled, yes, at the region of the head and face, what can be independent from our voluntary control? So the glandular structures, yes, what type of the glands do we have? They are mainly associated with the portion of the oral cavity and the digestive system. Why? Because here we do have the glands, which we call simply salivary glands. There are different types of salivary glands, out of which 3 pairs of salivary glands are the largest. These are parotid, submandibular, and sublingual. The names of these glands are really very logical. Okay, the part of the parotid is the one which is closely associated with the region of the ear. The part of the submandibular, from the name, it means that it is localized simply under the mandible or under the lower jaw. And the sublingual portion, this is the part which is associated with the tongue, so under the tongue. So particularly, please remember that out of these 3 pairs of the largest salivary glands, 2 of them are dependent on the parasympathetic innervation of cranial nerve 7, and these are particularly sublingual and submandibular. In the case of the parotid, you will ask, then what about the portion of the parotid? So parotid is mainly associated with the cranial nerve 9 or glossopharyngeal type of the nerve and its innervation, okay, rather than the facial one. From the other side, we do have also the type of the glands which are associated with the formation of the tear film on the anterior surface of the eye, and this is particularly the part of the lacrimal glands, yes, which are producing the tears simply. And you know that the tears, one of the most important function of the tear film formation. This is the protective mechanism or protective function, because the anterior, approximately 1/5 of the whole eyeball is literally exposed to the environment directly. Particularly the part of the cornea, as you know, is simply the most exposed part of the whole eyeball, and as a result it needs the protection, and this protection is represented by the lacrimal glands producing the tear film. Now, I do believe this part was more or less understandable. Yes, so let's continue and let's see what else do we have in the portion of the facial nerve. So when we talk about the function of the facial nerve, you can see that the first thing what we're talking about, this is particularly the control of the facial expression. Yes, so literally what is happening when we are when we produce, let's say like that, the different types of the facial expressions, whatever it will be. This is the result of literally a large amount of the different muscles which are subcutaneously localized, so very close to the portion of the skin and the subcutaneous tissues. And as a result, any contractions, even the small contraction of that muscles, are already giving us particular type of the expression. And simply to say that the superficial muscles superficial muscles of the face associated with the facial expressions are literally dependent on the innervation or on the nerve supply of the cranial nerve 7, which is the facial nerve, as we already said. Yes. Now, here comes the question, yes? So yeah, sure, this should be normally the voluntary type of the control, but we also do have some involuntary type of the control, which is dependent on the mood changes simply, and as a result, we can see some maybe micro, let's say like that, but still changes in the facial expression. So what type of the facial expressions we can see? You can find also in the case of the more clinically oriented anatomy, it's really very interesting to see that there are the different manifestations of anger, of pain, of, I don't know, of fear, of sadness. And to be honest, the most interesting thing that all of these type of the emotional expressions are approximately similar to in all of the cultures and all of the nations, and that's the most interesting part. That literally we can see we can recognize the basic type of the emotions in any individual. So what is also important in the case of the facial nerve to remember, yes, these are as we already said, the part of the parasympathetic with a part of the sensations, as you can see here. Now, but what are the main, let's say like that, components of the facial nerve? Yes, this is important for us. And one thing, and as we started to talk about, it was particularly the portion of the brachial motor function, so the first component, let's say like that. And mainly when we talk about the brachial motor, we talk about the muscular structures and the region, the tissues in the region of the auricle, as I told you, so the part of the ear, or simply to say, these are the auricular type of the muscles. Please remember that this particular type of the muscles are mainly originated from the portion of the mesoderm, according to the embryological development sure I'm talking about. And also what is interesting here, I want you to remember, please, that according to the embryonic development, the part of the muscles of the facial expression, they are developing particularly from the branchial arc, particularly the second branchial arc. I do believe you remember them, yes, how this particular branchial arcs, and out of which most commonly 4 of them are seen, but 2 of them are also present, like the 5th and the 6th one. So the second one is the most commonly the one which gives rise to particularly that type of the muscles. Now, as I said, just a second. Yes, I will continue with the part of the nucleus a little bit later. So again and again, parasympathetic innervation, or simply to say this is the one which we call also visceral motor type of the innervation, yes, is giving rise to the nerve supply of the part of the submandibular and sublingual salivary glands. That's what I want you to remember very well, as the part of the lacrimal glands, as we already said, yes. And in this case, here comes the important thing. And what is this? You remember that when I said about the parasympathetic innervation, and not only, I was just showing you the comparison of the somatic and autonomic innervation. Do you remember that? I showed you that somatic innervation, which we've talked about in case of the, for example, corticospinal pathway, where particularly we had the voluntary type of the control, yeah? We said that the nerve fiber which leaves the central nervous system, it doesn't matter, it will be the brain or it will be the level of a spinal cord, it is simply one long axon, yes, which is passing through the whole distance, and as a result then reaches the effector. Do you remember that? Or I do believe it's better to show you again to understand what I'm talking about, yeah? I will explain why I'm telling you that, because it will be clear. Just let me show you this portion, somatic, BS, autonomic nervous system. Once I even showed you that picture, and I told you that I love it very much because it very simply explains what I'm talking about and the main idea of these two types of two divisions of the motor output. Oh, it's small one, sorry. I do believe this one will be bigger. No? Let's recheck. Okay, let me make it simply zoom it and you will understand better and you will see it better. Okay, so what do we see in this case in front of you right now, yeah? So we do see the part of the somatic nervous system, and here you can see autonomic nervous system. And I told you that in the case of somatic, we do have always one neuron which contains a very long axon, where the part of the soma and the dendrites are localized, you see, in the central nervous system, and the part of the axon is traveling through the distance, particular distance, till reaching the part of the effector organ, as you can see here, yeah? And most commonly in this case, we do have acetylcholine as the neurotransmitter. Now, what is interesting in case of autonomic nervous system, you see that in any cases it will be sympathetic or parasympathetic division. You always will have two neurons in order. Am I right? And here one, so the first one, which we call preganglionic type of the neuron, its cell body and the dendrites are simply associated with the central nervous system. Then the axon leaves it, I mean the central nervous system, and it doesn't matter where it is. Again and again, I'm telling you, it will be the cranial nerves or it will be the part of the spinal nerves. But then we do have the passage of the first neuron, which is the preganglionic neuron, towards the part of the ganglion, where it finds the second neuron. I do believe clear that the name of a second neuron will be post-ganglionic, so simply after the ganglion. And here we do have simply the synapse. And in both of the cases, it will be sympathetic or parasympathetic innervation in the ganglia, so in the synapse between the preganglionic and the postganglionic neuron. Sure, we'll have the acetylcholine as the neurotransmitter. Now, why I'm saying that? As you can see, particularly here, in the case of, to compare the part of sympathetic and parasympathetic innervation, you can see that parasympathetic preganglionic neuron is one of the longest compared to the postganglionic. And this is the truth, to be honest. And that's why you see when we talk about the cranial nerves, particularly it will be the cranial nerve 3, cranial nerve 7, doesn't matter literally, the part of the cranial nerve itself, it will always contain the preganglionic neuron, yes? And as it travels towards the effector, in this case, it will be the lacrimal gland, or it will be the submandibular gland or sublingual gland, literally doesn't matter. It means that somewhere closer to the effector, closer to the gland, you will find the structure which we call simply the parasympathetic ganglion, yes? And normally, plus you remember that we've talked about that in the case of cranial nerve 3, we had there a very small type of the structure. This was associated with a part of the eye. Do you remember what type of the ganglion did we have there? We even said it. We even talked about that. Do you remember what type of a ganglion it was? Come on, let's recall this information, please. It was ciliary type of the ganglion. Yes, do you remember? So it was a ciliary type of a ganglion, which was associated with a part of the eye. We also sometimes call it the ophthalmic type of the ganglion, which is clear why, yes, because it is containing the pre and postganglionic neurons of the cranial nerve 3. So as a result, when we say about the cranial nerve 7, the preganglionic neuron is literally represented by the cranial nerve 7. Because please remember, and as you can see particularly here, comparing sympathetic and parasympathetic innervation, in case of parasympathetic innervation, the postganglionic neuron is really very small. It's really very short compared to the preganglionic one, you see. And as a result, that's why we can simply say that the preganglionic neuron is represented by the portion of the cranial nerve 7. Till now, was it clear what I said, or you want me to explain something again? Or we can continue. Just tell me and I will do it. Guys, are you with me? What? Of the postganglion? What do you mean? Postganglionic neuron. So that's why I'm telling you that the postganglionic neuron, most common in parasympathetic innervation, do not forget please, is so small that it is literally even, we could say, is associated with the gland itself. Because in this case, when we're talking about the cranial nerve 7, we do have here the two types of the ganglia. One of them is particularly the portion of the ganglia associated with the lacrimal region and associated with the salivary region simply. And in the case of the lacrimal one, we call it the pterygopalatine type of the ganglion. And in the case of the submandibular and sublingual salivary glands, we call it simply the submandibular type of the ganglion. What does it mean and how it looks like? You can see particularly here. Yes, here they are, particularly this is the part of a submandibular, as you can see here, as well as here you can see, okay, you can call it sphenopalatine, or simply the portion of the pterygopalatine type of the ganglion, which is also associated with the cranial nerve 7. So you see that when the part of the cranial nerve 7 passes, so the pre-ganglionic parasympathetic nerve fiber passes towards the ganglion. Here it is very closely associated with a part of the lacrimal gland, as in case of the part of the submandibular region, which is also very closely associated with the sublingual and the submandibular type of the salivary glands. That's how it looks like here. So as a result, what you need to remember, what you already know, yes, we do have the several types of the ganglions. These are, you already know about the ciliary ganglion, you already know about the pterygopalatine type of the ganglion, as well as the submandibular type of the ganglion, which are associated with the parasympathetic innervation of the cranial nerves, okay? This is what you need to remember. Okay, let's continue now and let's see what else do we have here, yeah? So, let me make it smaller to see better. So, in the case of the special sensory portion or function, yes, where we do have the taste, as you remember, we've talked about the taste portion. Yes, we said that anterior 2/3 of the whole tongue is dependent on cranial nerve 7, but what are the different types of the branches of the cranial nerve 7 which are giving rise to the special sensory and not only or type of the innervation? Yes, so in the case of the taste region, let me recheck if it's seen here particularly. Just a second. Yeah. So here it is. This is the part of our anterior 2/3 of the taste, and this is mainly this is very much dependent on the part of the portion or branch, let's say like that, of the cranial nerve 7. This is particularly the chorda tympani, and then the chorda tympani is the one which is then associated with the part. Let me show you it better because it's not seen here. Part of the lingual nerve. Oh, it's too big, too big. So here it is. That's what you can see here. This is the very nice type of structure. So, picture, which shows you the part of this. This is the portion of the chorda tympani. You can see that it contains the part of the special sensory portion here, as you can see, as well as the part of the lingual nerve. So all of them together are associated, and interesting thing that this joining, how they're passing together, these two types of the nerves, because the part of the lingual nerve is not a portion of the facial nerve. Please remember, the lingual nerve is the part of the trigeminal nerve, particularly its mandibular division. I do believe it's clear why. Yes, here. So both of them together are passing in the same region, as you can see here. Yes. That's how it looks like, but the portion of the chorda tympani is the part or branch of the facial nerve 7. Please remember that portion. Now, in this case, also, what do we have is when we said about the different types of the ganglia, yes, associated with the facial nerve 7, please remember that here particularly we do have 3 types of the ganglia. So 2 of them are mainly the parasympathetic one, which we already said this is the pterygopalatine type of the ganglia, as well as the submandibular type of the ganglia. And also we do have a small type of the structure which we call the geniculate type of the ganglion, which is a sensory type of the ganglion. It's not the motor, it's not the parasympathetic motor type of the ganglion, where particularly we do have the passage of the special senses, first of all, as well as here, that's what you can see particularly here. So we do have the special senses, so the taste sense, which is passing, as well as particularly we do have the the other sensory information, which is originating from the auricular region or the part of the ear, simply to say. Let me find better picture for you just to understand what we are talking about. For example, this one is also not that type of the picture, to be honest. Although, yeah, this one is even better. Yes. Yeah, here we do have how it looks like. So this is the part of the facial nerve, yeah, as you can see, but this is the part of the trigeminal. You can even compare how, according to the size, they are different simply. So this, the portion of the facial nerve is very much smaller compared, for example, to the part of the trigeminal, as I told you, which is the largest one, yes, which has this main divisions. So you can see that the portion of the facial nerve contains in the very close proximity the part of this geniculate ganglion, as you can see, and one of the important nerve or branch of the cranial nerve 7. This is particularly the great petrosal type of the nerve, as you can see here. Okay, so now let's go through the main branches of the cranial nerve 7. To be honest, I also do have it here, but it's mainly yes, here it is, the part of the greater petrosal. Yeah. So first of all, let's remember what are the main branches of the facial nerve 7. Sorry. The first one is the greater petrosal nerve. Okay. The very small branch, which is entering towards the stapedius muscle. All right. We do have also, as I told you, the chorda tympani type of the nerve, which are representing the most important branches of the facial nerve. Sure, it doesn't mean that there are no other branches. Sure, there are much smaller type of the branches which are also represented, but these are the three main which we will talk today about. Okay, so as you can see, when we talk about the portion of the greater petrosal nerve, yes, simply it is arising directly from the geniculate ganglion, as we have already seen, particularly in this picture also. That's how it looks like. This is our geniculate body or geniculate ganglion, and here particularly we do have the formation of the greater petrosal nerve. And then when it passes, most commonly it is the one which gives rise to the fibers or the innervation to the portion of the lacrimal glands, lacrimal region, as you can see also particularly here, yes. So you can see that as it goes through the main portion of the facial nerve, yes, so it enters towards the pterygopalatine type of a ganglion. Why pterygopalatine? Because I already told you that here we do have the parasympathetic innervation, which is mainly gives rise to the innervation of the lacrimal glands and even the portion of the nasal mucosa. That's what I want you to remember here. Okay, the next type and the very important type of the branch here, as I told you, this is the region of the chorda tympani nerve, and particularly the chorda tympani here. I told you that it is the one which is joining with the trigeminal nerve branch, which is the lingual one, and mainly distributed towards the anterior 2/3 of the tongue here, yes? So if we talk about the portion of the sensory information, in this case, we do have particularly the portion of the taste. So this is the main sensation here, but also we do have the part of the submandibular ganglion, yes, where it is associated, because you can see that chorda tympani, except for propagating the or containing the sensory fibers, also contains the motor fibers, yeah, as it reaches to the part of the submandibular ganglion, as you can see here, and also very interesting part, that the portion of the submandibular ganglion we can also call the submaxillary one. So, and particularly here we do have the parasympathetic innervation, as you can see, and as a result the part of the submandibular and the sublingual type of salivary glands are the ones which are mainly dependent on the on the innervation of the facial nerve 7. As you can see, also important thing that there are the other type of the salivary glands, because what we said about the submandibular, sublingual, the parotid are literally the largest ones, as I told you, yeah? But there are also a very small type of the salivary glands, which are dispersed through the whole oral cavity. And even their function is very much dependent on the innervation of the cranial nerve 7. But big exception, please remember, parotid glands are not dependent on the facial nerve 7, okay? Only this one is the biggest type of the exception for us, okay? So this is what we need to remember in this case. In the part of the, to make the continuation about the portion of the facial nerve, you can see here that I tried to put literally the most important information here, and I will not say again the branches and so on, but one thing what we remember, one important thing, that in the case of taste, we have two more type of the cranial nerves which are assisting the cranial nerve 7. These are the 9th and 10th one, as you remember, and also they are the ones which are entering towards the part of the nucleus solitarius. And in this case, when we talk about the passing and projection of the sensory neurons, as you can see, it also mainly enters towards the part of the ventral posterior medial type of the nucleus, as you remember, was in the case, for example, also of the cranial nerve 5, yes? So you even remember that when we've talked about the taste, we said that here in the VPM, or ventral posterior medial type of a nucleus of the thalamus, we had the ascending portion of the taste, particularly from 7th, 9th, and 10th cranial nerves, and then it was just simply entering towards the part of the gustatory area, yes? Because if you will compare the part of the cranial nerve 5 with the cranial nerve 7, yes? Although maybe it also was entering to the VPM, but what was the difference here? Their destination in the cortex. In the case of the cranial nerve 5, as you remember, the cortical destination was, again, somatosensory cortex, which I told you was the post-central gyrus, where particularly we had the Brodmann area 3, 1, and 2. And in the case of the cranial nerve 7, particularly here we have the special senses, and the special senses were associated with the special, it's like that part of the cortex. And if you remember, it was the gustatory cortex, which was mainly localized in the region of the insula. Do you remember this insula, the cortical structure, which is simply projecting, or not projecting, but invaginating, I guess, on the lateral side of the cerebrum. Okay, so important thing that what we need to remember here, these are the types of the nuclei, yes, which we have particularly in the case of the cranial nerve 7. And what you see here is the one of the important type of the nucleus here. This is the facial one, as you can see, and mainly it is localized, if you remember, at the level of the pons. Do you remember when we're talking about the brainstem? Yes, on the gross appearance of the brainstem, on the most posterior dorsal part of it, where it is providing the floor to the fourth ventricle, we said that there we do have the two prominences, spherical prominences, yes? And what are these two spherical prominences particularly? We call them facial caliculi. And as you remember, this particular facial caliculi that we had, they were literally, we even said that they were associated with the facial nerve, so cranial nerve 7. What does it mean, you will ask, how it can be associated there? So let me show you how it looks like, because here we do have, this is the cross section, or the part of the pons, as you can see here. Here you can see, as you remember, the part of the abducens nerve, which was the cranial nerve, and 6, and if you remember both of these nerves, it will be cranial nerve 6 and cranial nerve 7. They were originating at which level? At the pontomedullary junction, yes? And what do we see? Sorry. The part of the abducens nucleus, which is more medially localized, you can see, was surrounded by the fibers, or simply the fascicle, yes, a group of the fibers of the facial nerve. As you can see, that's why here on the posterior side of the pontine region, we simply had the projection, which we call the facial fasciculi, colliculi, as you can see particularly here, you see? And as we said, this is the portion which is producing the floor of the fourth ventricle. This is the region which produces the floor of the fourth ventricle, okay? And as we already said, mainly when we do have the passage of the facial nerve 7, it is mainly associated with the anterolateral type of the pathway. Why? Because it is simply what type of nerve? Mixed type of a nerve. Yes, that's why it was the anterolateral pathway or passage, simply to say. Okay, let's have some rest for 10 minutes for now. Okay, and I will be back at directly 12 and